Today on the Tech Bytes podcast, we talk OpenConfig and data models with sponsor Nokia. Nokia's SR Linux Network OS has embraced OpenConfig to help you support automation initiatives. We're going to talk with Nokia about why it chose OpenConfig, how it handles mixed data models for device platforms that may or may not use OpenConfig, and how Nokia is also using gRPC for streaming telemetry. Our guest is Igor Giangrossi, Senior Director of Consulting Engineering at Nokia. Igor, welcome to the podcast. And just for listeners, can we get a quick refresher on OpenConfig and its role in network automation?
Sure. Thanks, Ethan and Drew. Glad to be here again. OpenConfig is a project that was primarily created by some cloud providers and some telecom operators to help automating networks. And the goal is to provide normalization of data models and also create some interfaces or APIs to talk to the network devices. So then it becomes a vendor neutral and a device neutral way to communicate and operate with those devices. An example of that would be you have multiple vendors, multiple devices in your network, and you can configure, for instance, an interface in exactly the same way for all your network devices. An important point of it is that it's an open source project and it's not necessarily a standard through a standards body. So that difference is key because typically when you go through standards body, they try to create a standard that covers all bases and all corner cases. Whereas when you look at an open source project, the goal is essentially to fulfill the members or the community needs. So that's the target that OpenConfig takes to see what the community needs and push that forward.
So does that mean then, as Nokia, you are thinking about the needs of your customers and maybe data center operators in particular for this use case?
Data center for sure, but not only data center. There are actually a few large telecom operators that are part of the OpenConfig community that also push their use cases there. And their use cases are more like WAN or service provider, if you will, type networks. So it covers a very broad base of use cases.
And just sort of another high level question, why are data models and having uniform data models important for network automation?
If you look at a network automation goals, everybody will have a little bit different, but we can probably agree that you can come down to having machines managing your network and using some predefined processes that are repeatable and very well controlled. And the benefit of doing that is it allows the networks to scale more easily. It will bring some operational efficiencies, reduce human errors, be more agile, and even save costs. So in order for those machines to talk to these devices, you will need a language or an API. And if you really look at it, the CLI was the only API available from the beginning. And all of the networking automation projects in the past started using CLI. So essentially doing CLI scraping, where you would issue a command, get the output, and parse that output. Obviously, lots of challenges there because the CLI command might change. Even if the CLI command doesn't change, the output might change slightly. The formatting might change. Parsing those characters might be hard. You need to know what's a string, what's an IP address, the length, and things like that. So it was a very hard way of doing it, but that's how most people started using the CLI as an API. And that's where data models become important, because if you want to be really efficient in the way you have machines talking to network devices, you need to provide a well-structured or well-defined structure for all of the data that is available in a device in a format that can be consumed by the machines. And there are many ways in modeling that data. Yang is actually the language that is mostly used for networking data models. And that just makes it easier. If you can interact more easily with the devices, then you can much more easily build a networking automation system around it.
So with the need to choose something to do your modeling in, you ended up with OpenConfig, Igor, but for some that's going to be a controversial choice. There's plenty of people who have negative things to say about OpenConfig. So maybe you can explain why Nokia chose OpenConfig and then some of those challenges that go along with that choice.
Sure. And that's a great question. So let's start with the first part, which is why OpenConfig. And I'll just start by saying that obviously we do have our own native model as well as not only OpenConfig. So maybe the question will be, should we add OpenConfig to SR Linux or not? And our goal with designing SR Linux was to design the most modern operating system we could. That reflected not only in the internal architecture, how we built the system itself using cloud native principles and so forth, but also we had to put a major focus on network operations and how we would be operating networks into the future. And that means network automation. So the focus on network automation became very obvious. So the way we design it is we started with a model-driven foundation. So we said, no matter which model we use, 100% of all of the configuration, state, and operational actions must be available using some data model. And obviously, we developed a data model, a native Nokia data model, took over 100% of all of these. And this applies to every single process running in, or applications or services running in SR Linux, either developed by Nokia or even third-party applications or agents. And then we had OpenConfig, and we decided it was very important for us to treat OpenConfig with equal importance because we saw an increasing demand for it in the market. So it is a polarizing topic. Some people have had different experience with that, but there are a few large companies, and some of them are cloud providers. Some of them are large telecom operators that are actively pushing the industry to move towards OpenConfig. So we saw that demand, and we decided to take the OpenConfig support into SR Linux to the next level. So what we did was to make it easy to consume as many APIs as we wanted, and as many data models as we wanted throughout the system, the SR Linux OS. So not only we adopted the OpenConfig data model, but we also started to adapt the gRPC-based processes that are the APIs derived from OpenConfig. So gNMI, gNOI, we can talk about these as well. So that is another major focus of SR Linux, to be able to provide any API so that we can actually integrate into any existing network operations or automation environment. So that was an easy decision as well. And then we also started contributing to the OpenConfig community, where we developed a client for gNMI. We call it gNMI-C, and we actually donated the code as open source to the OpenConfig project so that anyone can start very easily testing and implementing gNMI through this API into their projects.
But importantly, OpenConfig here is additive. That's a key point. It's not just that you support OpenConfig; it's that you have your own full data model that fully describes SR Linux, and in addition, you're supporting OpenConfig, which connects you to that ecosystem.
Yes, that's correct. And that goes back to the second part of the question that you asked before. What are the challenges? So the main challenge of OpenConfig, being a community-based or community-driven project in an open source project, is that whatever the members want or whatever use cases the members want to adopt or develop will be what's supported. So if you have a use case where some of the use case or all of the use case is not supported by OpenConfig today in their data models, you cannot use it. Because there's been a large push and a very large expansion into support of many different protocols and use cases within OpenConfig. It has evolved to a very good place today, but there might still be some situations where you're not going to find some specific things into the models. And a good example of that is any innovation that any vendor or any special knob that any vendor like ourselves will put into any protocol, right? So you can have the base protocol support, but then let's say in protocol XYZ, we create some special configuration that allows you to do some special things that might not be covered by the OpenConfig model. So in that case, you'd have to configure using the data model that is native to that network device, in our case, the SR Linux native model. And we wanted to make sure those two situations were fully supported simultaneously within SR Linux.
Okay, so you're saying in a mixed model environment, Nokia can still handle OpenConfig, Nokia's own data model. Are there others that you can deal with?
Right. So we have our own data model, and we have the OpenConfig data model. And a big design principle was to support them or simultaneously or have them coexist. So we have a single shared database that is always written into the we have a single shared database that is always written and read using the native data models. So everything that gets written into the system or read into that database from that database will be in native data models. And we created a stateless translation layer between OpenConfig and the native data model. And that stateless translation layer also allows for transformation in case our native data model has the data using some different formatting than what the OpenConfig model needs. So we provide those transformations as well. So that translation layer is fully configurable, so you can actually see what are the exact mappings between the OpenConfig paths and the native model paths. So that becomes very easy for you to understand what we're doing. We fully expose that. And when you write or read into OpenConfig, the OpenConfig agents internally in the box will go through the transformation and will write back or read from the database into the native model. So that guarantees that there is no duplication of state or configuration. Any commits in one model will be automatically reflected in the other model. So that makes coexisting those two models very easy and very scalable. Another example of that is the CLI. So the CLI navigation in SR Linux is built from the YANG paths in the data model that you're using. And you can actually choose whether you want to use the native data model for the CLI paths or you want to use the OpenConfig data model for the CLI as well. So that provides very good flexibility for you to develop and understand and operate in both models simultaneously.
It feels like that's a translation layer as opposed to an abstraction layer. Is that fair?
Yeah, that's fair. That's exactly what it is.
So Nokia, you guys are also offering support for gRPC. So we should remind people what that's all about, Igor.
Sure. gRPC is a protocol designed by Google for RPC. RPC is remote procedure call. So it's a fancy way of saying I have two processes that I need to exchange data or information between them. That's RPC. So Google developed their own protocol for doing that. It's also an open source project, so you can actually go and contribute to the project. A little bit more details on it for the technical folks. It runs on top of HTTP2. It encodes the data in a binary format that is known as protocol buffers or protobufs that will handle all the data serialization, or essentially how you get the structured data and send that through the wire. So it uses a binary format, which will provide some native compression. That is a good advantage against, for instance, some other interfaces that use text or XML based information, especially if you're dealing with very large quantities of data. And also has some tools for managing compatibility, both backwards and forward compatibility, which helps a lot when you're evolving your system and especially evolving the data model. So it has embedded support by that. Finally, there's very good support in terms of programming languages for gRPC. You can today pretty much use most of the big programming languages to write software using gRPC. So you take Go, Python. I think those are the two more networking-oriented programming languages nowadays. But you can also use C, Ruby, Java, and many others as well.
So when I think about gRPC, I guess I think a bit about it in the context as an alternative to SNMP. Is that a valid way to frame it?
So gRPC essentially is just the protocol to exchange information. The alternative to SNMP would be how we use gRPC to exchange network management information. And that's where we go into gNMI. So gNMI is a protocol, is an interface called the Network Management Interface that is used to send and receive data between some sort of controller and network devices. So for instance, that's how we provide streaming telemetry. And that's also being developed by the OpenConfig project, gNMI. So that was the very first interface. And then the OpenConfig project started developing other interfaces for other tasks during the life cycle of a network. So the first one was gNOI, so Network Operations Interface. It provides us the ability to run remote operational tasks. For instance, we can do a ping, trace route. We can do software upgrades. And remember that these interfaces are meant to be multi-vendor or vendor neutral or even data model neutral. We don't need to use the OpenConfig data models. You can use the device native data model. So for instance, for gNOI, you could use gNOI to do a network-wide software upgrade, and that would be done in a multi-vendor network, multi-device network through a standardized process. So that's the value right there. Right. There's still another one that is a little bit more recent that is called GNSI, which is Network Security Interface. And that will provide security functionalities, as the name implies, authentication, certificate management, and things like that. So that's where we actually take gRPC as a fundamental protocol for exchanging information and take it to a use case level, either for managing network devices, the operational tasks, or the security tasks.
Yeah. Okay.
Igor, concluding thought here would be apply this for network engineers that they're seeing the benefit. That is, I could, as a network engineer, just go, Igor, the old ways are fine. I don't need your fancy gRPC, and I don't need OpenConfig models. I can just keep configuring the network the way I've been doing it for 20 years. And I'd be wrong, but would you explain why I'm wrong?
Yeah, absolutely. I think there's first a bit of a paradigm shift in the way we manage networks. So the SNMP model in the past had lots of challenges. So there were some standardized MIBs, but then when we go into enterprise MIBs, the situation is not so different than what we have today with OpenConfig, right? So there's varying degrees of support there. It's also an approach where you have a controller asking the devices, hey, send me this information, and the device would react and respond to that ask. So if you have a very large network, it becomes very difficult to scale that model. Nowadays, when we move to those data models with Yang and those types of interfaces, such as the ones we described here, for instance, gNMI, we can start to move from a paradigm where instead of a controller asking for information and getting all of that information back, where you might get relevant information, you might get just the same values as the last query. You can actually have your network devices stream information on demand. And yes, you can still do queries whenever you want, but by having that capability of pushing information on demand, you actually are sending just information when it matters. And it's a model where the devices push that information to a controller. The controller simply needs to receive that. So it's a little easier to scale to large amounts of data. So that's a little bit more modern way of doing this, and it will allow you to scale much further. That's the real benefit with those interfaces, as well as making it a lot easier to digest that data, because that data comes into, I would say, a more friendly format. Some people will say that Yang is not friendly at all, but at least it's defined. I'd say probably a better way of describing is a more defined way or standard way of looking into that data, so that you can ingest that data and do whatever you want with it, right? So I think that is the biggest advantage. And then if you can easily model each of those data models into your automation system, then you can start to abstract a little bit of the individual particularities of all of these network devices and go one level higher, which is really go to the intent level. So what do I want to do? I want to add a server. I want to add an interface into the network, right? And I don't need to go and look at specifically which of those devices are going to be in that specific compute, in that specific rack. You can start creating abstraction layers that allow you to focus on the intent rather than on specific configuration. And we are at Nokia also working not only on these approaches where we provide the data models and all of the gNMI, gRPC-based interfaces, but we're also working on some software layers where we solve that in other ways. If solving that through the software controller is your way to go, we're also working on that. But I think that's a topic for another day.
Well, Igor, you're obviously very passionate about this topic, and we'll have to have you back so we can get into more detail. But this was, I think, a good intro to what Nokia is doing with OpenConfig, gRPC, and others. And if you're curious on what you can do with it, just head over to learn.srlinux.dev. That's learn.srlinux.dev. We'll also have other links in the show notes with more details, including other episodes that Nokia has done with the packet pushers and some technical blogs from Nokia to help you get your head around this. Thank you for listening. You can find this and many more fine free technical podcasts and our community blog. It's all at packetpushers.net. You can follow us on LinkedIn. You can hear us on Spotify. And if you would, leave us a rating on Apple Podcasts, that would be great. And last but not least, remember that too much networking would never be enough.